All right, good morning, everybody. For those further back, you can come on up. We'll have a casual conversation this morning. So I'm very happy to have you here. We're going to be talking about architecting high-performance SaaS on Google Cloud. And we've got a great panel with very different types of applications and software. So I'm really excited to get into kind of how they think about infrastructure and how they're thinking about their products on that infrastructure. So I'm Leung. I'm a Director of Product Management for Compute and AI Infrastructure. And I'm joined by some great panelists, who will introduce themselves shortly. First, I'd like to just go over a little bit about just the basics of Google Cloud and our platform. So my team is responsible for the computing infrastructure. So that includes our general purpose compute, our AI infrastructure, block storage, and containers. So we're going to be talking about some of the typical properties of our services, but also some of the unique capabilities. So we have things like custom machine types, so the ability to specify exactly how many vCPUs and memory you need. We've got very, very good integration into Kubernetes, and there's a bunch of different properties of Kubernetes and our compute services to really optimize the usage of that infrastructure, including down to the type of consumption modes of that infrastructure. So we'll talk a little bit about that. We also have really, really tight integration with our block storage. So for those that are familiar with on-prem SAN, I think our offering is probably the closest to a SAN type of offering in terms of its capabilities around thin provisioning, performance provisioning, and things like that, again, to optimize the cost structure of the storage layer. And then, of course, we have a number of robust enterprise data protection technologies aligned with that. Here's our family. I'm sure you've seen large compute families, bigger ones that don't fit on a slide. I think our focus is on trying to find the right balance of choice and specialization of the compute shapes. Right? So we have our general purpose compute. We do have AMD-based Intel, as well as our own ARM-based processors called Axion. So we have our N and our Cs. The N's have that custom machine type. We introduced some new shapes of Intel-based Emerald Rapids instances this week. And on the specialized side, a number of different types of series, including storage optimized, memory optimized, as well as a new family called our network optimized that we introduced this week. Very, very high bandwidth, very, very high I/O characteristics for use cases that require that. And then we have our accelerator family, where this week we announced some new accelerators in our TPU family of compute. Okay. We'll talk a little bit about Hyperdisk, but primarily we'll be talking about compute today. And I think the most exciting part for me usually is how these things actually work in the software, in the products that our customers build on it, right? Whether you're a software vendor or you're just facing internal users. We've got a very, very broad set of use cases building and using our compute from companies like Shopify that are doing massive amounts of retail backend for businesses all over the world, to drug discovery, to doing fraud detection, et cetera. So lots of different great use cases running on Google Cloud. All right, with that, we're going to try to be as technical as we can in 45 minutes. So I'll have my panel introduce themselves, and we'll show kind of the key architectures they're running, as well as some of the backends, just so you can see it. And then we will try to leave some time for audience questions as well, so you can get some perspective from the panelists. All right, with that, I will start with Rohit.
Hey, my name is Rohit. I manage Prisma Access Engineering in Palo Alto Networks. Prisma Access is complete SASE solution, which lets users connect across the globe using secure methods. Main challenge for Prisma Access is applying security policies at wire speed. as I will talk through these architectures as we go along. Two of the things which I will talk forward as well. One of the thing is how Prisma Access is able to use container infrastructure for wire speed packet inspection, and how we are able to leverage C4E instances for us to get the cost benefit which Prisma Access offers as well.
Awesome. Thank you, Rohit. Hopefully you could see the picture, but we'll be coming back to this. Okay, with that, I'll pass it over to Gelu from Kinaxis.
Hi, good morning, everyone. Thanks for coming so early. Gelu Ticala, Kinaxis, Chief Technology Officer. We are solving problems for Fortune 100 companies in supply chain and operations, so very complex domain. We built an in-memory database I'll talk a little bit about later that's purposely built for those kind of very complex problems that require lots of memory because there's lots of data, and there's also requires compute. We're using M-series. Again, we'll talk about that, and the VMs and the Hyperdisk. Very, very good solution in terms of cost. One of the reasons why we aim for that is because of the cost, the price performance, and looking forward, obviously, with many, many agents doing lots of that load, it's going to be interesting to see how we can scale that.
Awesome. Thank you. And then Murray with Snowflake.
Yep. Good morning, everybody. My name's Murray. I'm an architect at Snowflake. Specifically, I work at the intersection between our software and systems and the cloud infrastructure that we run on. So my focus here is getting the best price performance possible. So looking at the ways that we can use new cloud technologies, such as the ones that were just announced, the different workloads that we have, how that maps best to the different VM shapes, how we can optimize our usage, and continue growing in regions around the world in a cost-effective way. So that's kind of my niche, and it's been a fun ride.
Awesome, thank you, Murray. And then last but not least, Ben with Mongo.
Hi, my name is Ben Flast. I'm the director of product responsible for search, vector search, and our Voyage AI models. And we really value our partnership with Google around kind of the flexibility that they give us in terms of having the different kind of components that we need at various points. So we build a transactional database as a service that sits inside of clouds like Google and uses all of the primitives that they offer, so it feels just like a native database. And what's really crucial is for us building the service that we have access to as close to kind of bare metal primitives as possible, right? We're working on the order of nanoseconds. And so every kind of hindrance that we have in terms of being able to get as close to the hardware is really challenging. And so all of the flexibility that Google gives us is really crucial and has allowed us to kind of build out what is a pretty novel architecture where we've taken search and vector search and collapsed it into the kind of transactional database world. And we'll be excited to talk about that today.
Awesome, thank you, Ben. Yeah, so hopefully you're seeing that it's a really nice variety and diversity of different types of workloads that are going to really be using the infrastructure differently. So let's get into some questions. Okay, so first, I do think a lot of companies have gone through this thought process of, what type of processors do I use, right? So the good news is that ARM has been in the cloud for a little bit now, and containers and Kubernetes as well. So as I said, we do have these offerings in our cloud, and oftentimes customers are going through the analysis and the trade-offs between these two things. So, maybe I'll ask you the question, Murray. So when you were thinking about your architecture for Snowflake, how did you kind of go through the process of the compute infrastructure?
Yeah, absolutely. So price performance is the key driver, the key metric that we're looking at when we're evaluating our compute platforms. So the Snowflake Data Cloud, the key concept has always been a disaggregation of the storage and the compute. So you load your data, you transform your data, you store it on blob storage, and then when workloads come in, we want to scale up immediately to meet the need for that, to then scale back down when you're not using those resources. And so how efficiently that we can scale up and perform those queries helps the customers get their workloads done faster and help at lower cost. And so then how do we evaluate what works best for those workloads? We do this at sort of multiple time horizons. So obviously once we've got silicon in the data centers, and we can evaluate like the new the Axion instances versus the older Intel or AMD instances. We can run A/B tests and we can gather data. But we really want to start years ahead of that process so that we can really be ready as soon as the new hardware is announced. And so we do that by building out performance models, by having a collection of open source benchmarks that correlate well with our workloads, so that we can sort of share those with the account teams, share those with with the folks that we're working on to sort of understand what types of performance might we expect from this workload. It also helps internal teams as well, and there's a couple examples of that. So we've been on ARM for a long time, and one of the things with early ARM platforms we found was, well, two things actually, was like branch misprediction costs were much higher. So some of our large multi-threaded Java applications had sort of poorer performance than we might expect on early ARM architectures. And another example would be SSL, anything that was doing high network throughput and encryption. We weren't using the multimedia extensions in early ARM versions, and so those had a performance penalty. But by having a sort of a collection of benchmarks that sort of can tease out which of those things we're hitting, we could identify early on which would be affected by these, which we might sort of keep on Intel or another platform for a short period of time. And then ultimately, it helped convince the service teams very rapidly when the new Axion processors eliminated both of those bottlenecks that we saw with earlier ARM architectures.
That's great. So, so you were helping the engineering teams kind of understand the profiles of these workloads and these instances to help get them on board.
Yeah, exactly. So looking, is it memory bound? Is it compute bound? If it's compute bound, how much is the branch misprediction penalty going to be? How much is single core performance going to matter? That sort of thing.
Okay, great. And then Rohit, you've also adopted the Axion as part of your stack. Can you talk a little bit about that, as well as Kubernetes?
Yeah, I'll start with Axion first. Prisma Access as service has been using AMD and Intel in the past. When we use different cloud, one of the goals we have is to move to ARM, given the price and the cost it brings to us. What unique C4A brings to Prisma Access, it provides 2 core instances as well. In the past, we have struggled where the ARM instances in different clouds are only available in 4 cores or 8 cores, specifically for those customers which are requiring dedicated workload for them. ARM instance 2 core is a big change for us. It gets us the price performance, and it achieves the isolated security outcomes, which those customers are looking from us as well. I will come to the use of container infrastructure, which Prisma Access is using now. It has been my dream to use container infrastructure for security workloads, specifically when you are inspecting packet at wire speed. In the past, we have struggled with packet performance in container form factor. With CNI v2, with GCP offered, which uses eBPF filter now, we have avoided all the packet copies. If you use container framework with eBPF filter, which is part of CNI v2, you can get as performance as you get with VM form factor as well. Prisma Access launched the product this year using this new infrastructure called CNI v2. One more thing which GCP offers, if you're moving to container workload, is called Container Native Load Balancer. It makes sure that it avoids all the latencies when you're talking across container workloads as well. So 2 innovation, Container Network Load Balancer, in addition to Tier 1 networking, which comes with CNI v2, which makes you get the same performance as you get with VM form factor. Prisma Access is using both of them and is giving us the outcomes in terms of performance, as well as in terms of the cost benefit it brings to Prisma Access.
Yeah, so on the Axion point for a second, I think you and I talked a little bit about kind of the load profile of your customers, where because your customers oftentimes are enterprises, the traffic goes down at night, right? So, so as you were thinking about that, talk a little bit about that and kind of using 2 core and whatnot.
Yeah, Prisma Access is a 24/7 service. People connect to Prisma Access all around the world. But the people, when they connect in US, they don't need those instances in the night time. Similarly, when people are connecting from far remote, they may not need those instances in their night time. With C4A 2-core instances, it provides us flexibility where we can bring them on demand as the customer workloads come there as well.
Yeah. So anyway, I feel like I could spend a ton of time talking about these characteristics where there's the technical aspect, but then there's the business aspect of, right, when your customers are using the infrastructure and how do you optimize for that. So awesome. So let's move on to the second question briefly. Okay, so implementing AI into the application or into your set of services. So whether it's generative AI or other different types of machine learning, you and I talked a little bit about this, Ben, in terms of your platform and how you think about AI and how you're integrating it into your products. Can you comment on that a little bit?
Sure. So, we're a bit interesting in this kind of, world where we both are integrating AI into the product to make it easier to use, right? So when you go into MongoDB Atlas, we want to give you affordances for generating queries, crafting indexes, et cetera. But also, very intentionally, the reason we have a search and vector search product integrated in the database is so that you can use it to power your AI-powered experiences. And with our acquisition of Voyage AI last year, we brought embedding and re-ranking models into the fold. So with vector search, you can bring your own vectors, store them in the database, and create a new secondary index on top of those vectors that will live on your search nodes. Then you can execute vector search queries against the data in your database. The thing that we're doing with the Voyage AI models is that we're bringing them as close to that database experience as possible, and really kind of like blending them into the query experience overall. So as like an application developer, if I need to be embedding my data before I insert it into the database, or I need to do re-ranking of my query results, we want to make that as seamless and simple for you to do in a very performant and easy manner. And so we're taking those capabilities and kind of directly integrating them into the database. And one of the key benefits of using Google for a lot of our inference serving capabilities is that there's a ton of flexibility, and one unique bit is that you can provision a single GPU, right? And so that's quite rare among the cloud providers and gives us kind of just a ton of flexibility to really right size the GPUs and kind of serving infra that we're using to power these experiences.
Does this, I can't remember, does this picture kind of show that flow that you talked about?
No, so
okay.
This shows the core database, right, which is your MongoDB, so a 3-node replica set, which is how we give you kind of high availability and data durability. What I like to think of as somewhat ephemeral search nodes, which are storing your secondary indexes and power search and vector search. But each search node is, a little kind of ephemeral in a certain sense, kind of, pets versus cattle type scenario. And then outside of this, we have a whole set of serving infrastructure, which is integrated in at the data plane. And so this doesn't include that part. This is the core database product, and then we have a separate inference serving multi-tenant service that is kind of integrated in at that query layer.
Great, thank you. So Gelu, you and I talked a little bit about your AI adoption. I think we're talking about agents.
Yeah, well, we're doing a couple of things with Google technology. One of them is the Gemini models that we're using for agents that do more like chat with data, so pretty good performance there. And then if you think about agents in general for our software and our customers, you have everything from how do I onboard new employees faster. There's like 5 generations of people working in supply chain. That's an interesting challenge there to chat with data, as I mentioned. And then more towards playbooks that these agents are capable of executing, which involves literally thousands of simulations. One of the things that we're doing well in our software is the simulation, the versioning of data, and the ability to run the simulations at a very high rate. Agents are operating in a sandbox. They work towards an outcome, a business outcome that has been assigned to them. We're using GKE to orchestrate all that load across thousands of agents.
Is that meant to be kind of a companion for the person that's interacting with your system? Can you?
Yeah, so it started like that and moving more and more into kind of a more an autonomous agent where it can operate, take actions, basically write into the database and make decisions within a guardrail with human on the loop, of course, and then just basically provide solutions to supply chain challenges.
So that's so your application, I would say, is pretty mission critical, right? In terms of determining how the supply chain is organized.
Correct.
But you're actually
Yes.
exposing an agent for your.
People weren't aware about supply chains till 2020 when the whole COVID started. Everyone was we're very popular. Everyone talks about supply chain. So you have like massive disruptions probably every minute in this Fortune 100, 1,000 companies. And so we help them deal with those unexpected exceptions and disruptions to the point where they can make hundreds of millions of dollars decisions based on how these agents and how our software operates. Yeah.
Okay, great. So maybe jumping into a little bit about kind of performance decoupling, compute and storage decoupling. I think you and I talked about this a little bit. I mean, Snowflake has an architecture already where you've been thoughtful about your compute and storage layers. Can you talk about how you've kind of evolved that on Google?
Yeah, absolutely. So as I mentioned, the two major components would be the data at rest stored in blob storage, and then the compute nodes spinning up and down based on user demand on the compute side. And a couple of features of GCP have been pretty instrumental for us. Number one, just briefly on the storage side, the auto class feature has been fantastic for us versus some of the other cloud offerings. And so this, for those that don't know, this is a class of storage which is looking at access patterns and automatically demoting the seldomly accessed data to colder storage tiers and elevating the hotter data where it's available. And we've found both from a performance, latency, and cost perspective that auto class is working quite well in allowing us to reduce the cost of storage for our customers. So it's been a great product. And then on the compute side, the main thing we care about is VM provisioning latency. When somebody comes in with a large query, how quickly can we spin up instances to fetch that data, service that query? And we can't get it in the order of milliseconds that we might like, and so we do have to maintain a pool of ready-to-go servers, a free pool that's already provisioned. But the speed at which we get them back from the cloud provider dictates how large that free pool needs to be. And so we have a number of operational metrics about this, and obviously it differs by region and by VM. If you want the same VM at the same time as everybody else, like at the top of the hour or something, you might have slightly higher latencies, and we have to predict for that. But in general, we've been seeing good momentum in sort of getting those VM provisioning latency times down, which has helped us to scale up and down more efficiently on cloud, including with the new Axion SKUs. So I think that's been a key part of it, and it's been really helpful for us.
So architecturally, maybe in this diagram, so when you're serving a warehouse, are you loading the data into that virtual machine as a cache?
Yeah.
As picture?
So three major components of this: the data at rest and the persistent data store, and then we have a global services layer that is interacting with the API or the user interface in the web. That's taking the query, doing query planning, and then pushing that down to our execution platform, which is the thing that scales out across all the nodes. That part of the execution platform, that's passed down from the global services layer a list of blobs that it needs to fetch to do the scan for the data that it has. And of course, as with any database, we're trying to do absolutely as much pruning as possible so that we limit the amount of data that we need to only the ranges of columnar data store, and looking at the min and max of each micro partition, and doing all these techniques to try to fetch as little data as possible while still answering the user's query. But then yes, fundamentally, each of those what we call XP nodes is fetching data from blob storage, scanning it, processing it, and then doing the joins and aggregations that are required to get the user's data back to them. And that would be at the virtual warehouse layer in the middle here of this diagram.
Yeah, so I love that architecture we talked a little bit about your architecture and how you're thinking about the different trade-offs there.
Yeah, so I'm defending the M series, I guess, with our architecture because we're very memory intensive. As I said, we have an in-memory database that we developed it over the last 20 some years when in-memory wasn't that interesting. Just because of the sheer amount of data that we had and the types of computations that we want to do on that data. So we designed that in-memory database to be kind of NUMA line architecture and also to support that high memory to CPU ratio, which the M series gives us. So what basically happens is, so we have our own way of allocating memory, the way we store data in memory. Then we have an SDK that goes after those data structures that database has. And then we have these computations, mostly like heuristics and meta heuristics that are very complex, very performant. Imagine we can do operations that get to 95, 97% accuracy when you compare with a solver, like a Gurobi solver, in terms of accuracy of the response in like seconds versus many hours, right? So for that, you need to be able to access data in memory. The way we store it in memory is very well aligned with how it's going to end up being used. So when we grab data from memory, we put it in the cache lines in the processor. So we need processors that have like a high clock speed, and then we can do those computations very fast, right? So that's kind of where we see the benefit of the M series, and we have customers running on 12 terabytes instances. So
yeah, so your model currently is to deploy that M series instance, basically dedicated for the customer.
Yeah.
Deploy your software into that instance.
Exactly.
We talked a little bit about how you're thinking about potentially evolving that. Aspects of it for multi-tenancy.
Correct. Yeah. So going forward, we're looking at scaling out a little bit more. Historically, we've been, riding a more slow and scaled up a lot. But we do see now, again with agents and the heavy increase of data and users, be it digital or humans, we see a need to scale out as well. So that's where Hyperdisk is going to also come into play for us. It does come now with disaster recovery that we have, but that's going to be looking forward to see what else Google is coming up with in terms of compute architecture that will align nicely with our next gen.
Yeah, I think it's interesting to kind of think through the storage layers, whether it's within the instance, whether it's a persistent disk, whether it's a shared disk.
Yeah, like
or
there's
an object storage.
Yeah, exactly, like multiple layers, and depending on who's using the data for what purpose, you do store it at the right level.
Yeah.
Memory is king, right? If you need fast access.
Yeah. Is that something you could comment on as well, Ben, in terms of the different ways you use the storage layers or the data layers?
Yeah, absolutely. So disaggregation is key, similar to what we're talking about with Snowflake. It's a bit different for us since, as a OLTP database, right, it's kind of like very low tolerances around kind of any latency at any point in the stack. And so at the same time, while the database has certain characteristics that it needs out of its storage, search nodes have a different set of characteristics. So, the database is, BSON-based storage with B+ tree indexes. And like generally you bring that data into the working set and then you're querying over that data and you're getting like really low latency. A bit differently inside of search node land, you are keeping most of the data on disk and you're memory mapping it in, and then you're fetching slices of your index from disk. And so the database is going to be less reliant on necessarily having as high IOPS, but also it's probably not going to need as low seek times for the disk, whereas your search nodes are. And so the ability to kind of have different compute, but also different storage profiles for these different types of nodes is really what allows us to kind of optimize the different part of what has become like a very kind of both disaggregated, but also like asymmetric architecture around the types of use cases we solve. And so with this, you can really have one user interface, one experience for a developer connecting, but all the different types of infrastructure primitives that would need to sit underneath those algorithms to enable the performance for each different type of workload characteristic that is now falling on one OLTP system.
Yeah, that's so a follow-on question is actually our last question. So, so how do you translate that into your product and kind of your business model that you're exposing to customers, and that kind of the disaggregation, kind of the right sizing you're talking about? Yeah.
Yeah. So the disaggregation comes down to explaining to the customer really the primitives that they're getting access to. So how many CPUs are they getting access to, so they can think about kind of QPS metrics, how much memory they have access to, so they can think about kind of right sizing it to make sure either the segment of the index or the entire index can fit into memory depending on what type of index they're using and what type of use case they're solving for. And all of this kind of boils down to having that like flexibility to plug those different things together. And at the end of the day, we take advantage of like various parts of the platform outside of just kind of the VMs themselves, whether it's object storage or otherwise, to kind of make it highly available and kind of ready for whatever workload changes you see.
Yeah, I think you've been able to use some of our flexibility, and then again, kind of expose that to the customer to right size it, and so they're getting the right performance, but the right profile, and then that reduces some of your cost structure behind the scenes, right?
Exactly, and just like in terms of kind of how the customer experiences it, we give them those primitives that they need, but they don't have to think about things like disk seek time or other kind of like really low level kind of characteristics of the solutions we're taking from Google and packaging. They can really focus on what are the latency and QPS requirements I have for my specific workload. So the customer gets like a more simplified kind of picture of figuring out how to solve their use case with the database and not needing to think about kind of all of the different characteristics of the underlying service.
Got it. So you and I talked a little bit about business model as well and different product models. Can you talk about how Palo Alto is thinking about that?
Yeah. Some of you may know Prisma Access also offer Prisma Access browser, which we call it a secure browser for everybody use. It provides you security in the browser, which you don't have to install your client itself. This year, we launched a new product, which we call as Prisma Access Connector or Prisma Browser Connector. This is built on the CNI V2 infrastructure, which I already talked about. Using Prisma Connector or Prisma Browser Connector, you can bring up your extension on the browser or the new connector within few seconds. The complexity of installing and operationalizing it reduced by 10 times. In addition to Prisma Access cost, which has gone down by 50%, because of use of this architecture. Again, this is a fundamental shift because ability to use container infrastructure for packet performance was not there before. Now we can spawn more containers. As the load goes along, we can bring the simplicity to end customers as well using the Prisma Browser Connector.
Has it enabled you to access like a smaller customers versus the large enterprises?
Yeah. One of the challenge Prisma Access browser always had was entry to the SMB market. SMB market has a different dimension, specifically one-click deployments, simple to use, and that's what Prisma Browser Connector provides to us. It makes us entry easy to SMB market, and today Prisma Browser and Prisma Browser Connector is available for all SMB market. We launched it this year as well.
That's great. And so the direct translation maybe of some of the technical benefits, we could probably talk about CNI for quite a bit, but just compute costs as well, right? Kind of reduce your cost structure to, again, make it a profitable business to go down market a little bit.
That's true. Entry to SMB market, there are two critical things, simplicity and the cost structure, which makes you successful in SMB market. This infrastructure provides us both.
Awesome.
I mean, that's the case for us. When we moved from on-prem to cloud, we could just completely change. Even for me as a technologist, I can understand those business impacts, like going from a heavy CapEx business to an OpEx. That completely changed the way we are becoming profitable, highly profitable in that kind of model. The other thing is the price performance. Used to be maybe not great 5-10 years ago, but that's completely changed now. You get pretty great price performance ratios. And last but not least, I mean, if you think about the memory shortage that we all see these days, I don't want to deal with that, to be honest, as a trying to secure that compute and memory capacity for our data centers. So Google is very good at that. So.
Yep. And it's a great story of, again, kind of transitioning from on-prem, very high hardware specification requirements,
correct,
and being able to leverage that in the cloud.
Yeah.
So
yeah, it's massive impact on the business.
Yeah. And you and I were talking a little bit about Snowflake's products as well, and your use of ARM and your kind of differentiating of different your product family. So can you talk about that a little bit?
Yeah, we're very excited about our Gen 2 warehouses and our adaptive warehouses, which is sort of the future of the Snowflake compute platform. So traditionally, when you're launching virtual warehouses in the middle part of this diagram here, you're specifying a size parameter as well to help you. If you've got large, intense, memory-intensive queries or large hash joins or different things, you might need a larger size warehouse to compute that workload faster and more efficiently. However, you're managing this virtual warehouse in that case. You might have to set up, an auto-suspend time after how long before the compute sort of spins back down after your last query and things like that. We're moving to an adaptive warehouses model where we take away more of that complexity, more of a serverless model, so you can come up and you can, it'll adapt automatically to your query types, and it gives you one less dimension that you have to worry about for your workload to let our software optimize it on your behalf. And we're launching all of that on the new Axion platforms, which has been exciting.
So then a customer coming in, instead of having to, I don't know exactly how your UI works, but instead of like having to provision a shape, let's say,
exactly,
right, or think about capacity, it is more serverless then.
Exactly, yeah, and workloads change over time, right? If you've got a nightly job, you may be processing more and more data, and at some point, the size of warehouse that made sense at a given point in time, you may outgrow that. And so that's why we're very excited about things like adaptive warehouses to automatically tune that for your workload, for the data that you're processing at that amount of time. It tends to give better performance for customers and just be a better model overall, and so we're very excited about that.
Yeah, and you were able to do this in part because, again, you got some really good price performance on the Axion.
Yeah, absolutely. Especially if you look back at some of the Intel instances that we were using previously, we saw huge benefits, 50% or more latency reduction, performance throughput improvements, the DDR5, the extra memory bandwidth across all the dimensions for different types of queries, different types of workloads, AI workloads. We're seeing significant improvements, absolutely. We've got a blog post where we kind of go into some of those different types of workloads and what performance differences we saw in different workloads there, for sure.
Very cool.